Okay, so really quickly, I know it's the end of the night and you're all bored, but you can tell by the color of my hair that I've been doing this for a long time. So I was an undergraduate in 1980. I programmed in Pascal on a DEC 10, and I punched cards to put the program code and the data in. In the mid-1980s, I was a junior programmer on the first commercial email systems. So email is partly my fault. And we have a sort of a problem with the technology here, so I'm going to try and talk to you tonight about history of distributed computing, why GraphQL, what's it worth, and then some Uncle Pete's advice. All right, distributed computing. Unfortunately, this was supposed to be this animated build that goes across here, but it doesn't work. So let me talk about the history. In the 1970s and the 1980s, every hardware company had their own software, and they had their own networking stack. So if you look at IBM, they had SNA, and LU6 was the way an application spoke to another application. In Digital Equipment Corporation, they had DECnet, and they had channel-to-channel communication. Wang Laboratories had Wang System Networking, and it had a remote port. And then TCP/IP, everybody had a version of TCP/IP, and it was a socket communication. So this was inter-process communication, where you as an application developer would build some kind of message that you could send to some other application. So that's what you got in the 80s. 70s and 80s. In the late 80s, the notion of remote procedure call arrived. This is where you had a stub that looked like your subroutine that you called. It did some kind of serialization, and you had a skeleton over here that invoked the subroutine you were going to call on a different machine. And this blue pipe, this network pipe, was the connection between the two things. And it didn't matter what the protocol was or what the network was. You're all too young to have remembered a circumstance before there was TCP/IP, right? Okay. So that's what we got. It became a familiar paradigm because people could call subroutines really well. They were really terrible at writing network transactions. In the early 90s, there was this horrible technology called distributed computing environment, which hoped to standardize RPCs. It was disgustingly horrible. That's the best way I can describe it. So I did my master's degree in distributed computing in the early 90s, and so I speak DCE, although I don't like to own up about it. Like, I don't talk about it at family gatherings or at Christmas or anything like that. It's quite embarrassing. In the mid-90s, there was this other thing called CORBA, Common Object Request Broker Architecture. In fact, my master's thesis was Distributed Objects Approach to Client Server. So we did a lot of CORBA in that. About the same time, you had DCOM, which was Microsoft's Distributed Common Object Model. So later that sort of evolved into ActiveX and things like that. So what you got there was distributed objects, a bunch of services that help you get the job done, and an interface definition language where you could describe the object itself and the operations that it used. That was a lot of fun. Then in the late 90s, so this is when Java arrived. So when I first saw Java, I thought it was going to be a great job creation scheme for the IT industry. You had to do so much work to get something done. Of course, Java was going to solve world peace, okay, solve hunger, and today if Java was invented, it would solve global warming too. So in the late 90s, you got RMI, Remote Method Invocation, that was a Javaized version of CORBA. It sat on top of TCP/IP sockets. It had its own protocol. And it was an unusual way to code. Painful. Then it got worse. In the early 2000s, someone who was obviously smoking something, invented SOAP. The S in SOAP stands for simple. Now that's a lie. When I first saw SOAP, after I've just done this 90s worth of distributed computing, I went, okay, so we're going to take a short, compressed binary protocol and we're going to do it all in XML. So instead of sending mice across the wire, we're going to send elephants. And that made a great deal of sense because it could go through the firewall. I don't know anybody who actually implemented anything but the SOAP protocol. All of the other stuff, the service discovery and the name discovery, nobody bothered with. It was horrible, horrible. And then we got REST. So the best way to sum up REST is it's sensible SOAP. It really is a simple interoperable protocol. It's based on the stuff that makes it easy. It works. And anybody can do it, right? You're all professionals. You're good at your job. There's probably someone in your organization who isn't quite as good as you. And they can still do it, right? They can go to curl and type in the commands and they can still do it. So then this funny thing called GraphQL came along. So what is GraphQL? It's a query language that allows you to do a remote procedure call and get an object graph the shape that you're interested in. Okay? So an object graph the shape that you're interested in. You're all JavaScript people, you know what an object is. So why should we bother? Okay. So GraphQL is a protocol or dialect. You will notice that I speak English and I sound a bit strange. I'm not American and I'm not British. So there must be some other dialect of English that I speak. I'm Australian. We can make all the jokes about throw another shrimp on the barbie and that's not a knife, this is a knife. And then I could talk like a real Australian and talk with Struth and say, "G'day, how are you? No worries." But I won't. So this protocol or dialect allows you to do a read model, a write model, and a notification model. So the read model is the query. The write model is the mutation. And subscriptions are a kind of notification, distributed events. What else you get with it is a type system. So you specify the entities or the domain objects that you want to pass in advance. It's strongly typed. So think of the definition section of Swagger. It's kind of like that, but more strongly typed. You can also specify a hierarchy of objects, so not quite, but almost inheritance. So the good part of inheritance, interfaces, so specification inheritance, not the bad part of inheritance. Particularly, you can specify relationships. So in the ad tech industry where I work, we have the notion of a campaign, and we have the notion of an order, which represents some money somebody's paid to fund that campaign. And we have this notion of a line item, which is a stupid name, but it represents an execution plan of how much of that campaign is going to be run. And then there is an advertiser. And all of these domain objects or entities have a relationship with each other. So in GraphQL, you can specify that relationship. So you end up with a schema that is usable. The schema has introspection, so you can peer into it from browser land or front-end land or client land and see what it is. You can put documentation in it. You can deprecate parts of it. So it's focused mostly on data and the operations you do around them rather than just the operations themselves. Okay, so why would you bother? Why would you use GraphQL? One of the first reasons is you might have more than one client. So you might have a web application that needs to talk to the back end. You might have a mobile application that needs to talk to the back end. You might have an Alexa application that needs to talk to the back end. So you have multiple front ends, multiple user interfaces. So that's the first thing. If you care about latency and bandwidth, so if you're sitting in your desktop computer, certainly here in Europe where bandwidth is unlimited and it costs you no money at all. It's very cheap and very fast. And then you go to somewhere like just outside Hyderabad in India, where your mobile phone switches all the way back down to the edge network, bandwidth becomes important. So GraphQL helps you with that. If you have a microservice architecture, I'm not going to talk about microservices. That's a whole topic in itself, but if you have a microservice architecture, it's great. Okay, so we found that, that REST had become so complicated that it was starting to be a drag on business. If you have a set of REST APIs, and instead of you having 10, you now have 500, or 500 with 3 versions, which means you have 1,500, that's going to be a drag to maintain. And I know you give it to the junior programmer who's just joined the company because you don't want to do it anymore, and they have to, do all the terrible jobs. The other thing that GraphQL can do is decouple the front end from the back end. One of the worst things is when you look at an API and you see some leakage of a front-end requirement built into the API. Instead of it being an RPC call to do some operation on some data, it now has something like, get me my shoe size in English or get me my shoe size in French. And that's a front-end responsibility. Okay, GraphQL gives you one endpoint. Instead of having 400 or 4,000, you can end up with one because you put the body of the query in the post request. So instead of having get customer by shoe size, get customer by eye color, get customer dancing on one leg, swinging a hand around your head, you don't have to have all of these endpoints. You can have one. And so one is much easier to deal with than many. The other cool thing is you can get everything you want in one request. And I'll illustrate that a little bit later on. These two here, versioning and deprecation, they go together. Let me move that mouse pointer so that we don't have that over the word. So no versioning issues. Of course, things change. Okay, I used to be young with dark hair, handsome, attractive, suave, sophisticated, and now I'm just older. Okay, so things change. Things change. The way you deal with versioning in GraphQL is that you can deprecate things. You can deprecate whole types. You can deprecate operations. You can go down to deprecate fields or parameters on fields. You put a little tag in the schema definition, and then you can say what to do instead of it. And in deprecation, you leave it there for a year or so, and then you tell everybody who uses it that we're going to cut it off tomorrow. No one pays attention. Then they phone you and say, my API doesn't work. Remember those emails? Okay. Schema discovery is great, and I'll tell you why schema discovery is great in a few seconds. So what's wrong with REST? Nothing. REST is the most sensible thing that happened to distributed computing since somebody finally slew the soap monster. But Adform has 400 endpoints. And then we have 3 versions of each one. So some poor, soulless sap has to maintain all of those. Maintain all of the swagger. Maintain all of the implementations. Some of them are in C# and some of them are in Scala. So then there's all of those variations. You might have a problem where you get the whole object, you get the whole elephant, where you only need the tusk. So who's called an API like that, where you've made this call and you get this huge body of data comes flooding back and you want this bit? but it's the only API that'll get you that bit. So you have all of the obvious problems of sending elephants across the wire. What happens is, in the magic of computing, the fairies come along and they squish the elephant down into this little tiny thing. But the elephant still weighs the same amount. So the density of the elephant goes up and it waddles across the wire, and the fairies at the other side put the elephant back into space, and then you grab its tusk. That's dumb, okay? In fact, Uncle Pete would call that FD. D stands for dumb. F stands for fundamentally or flaming dumb, okay? Or something else that starts with F. All right. We have in Adform this problem where we have multiple endpoints that return the same thing, but the thing is different. One example is we have a campaign. A campaign object describes some type of program to sell you Coke or cigarettes or something like that while you're on the internet. And a campaign should have a certain shape. Well, in our APIs, one of the endpoints in the same microservice produces the campaign status. The type of the status field is an integer and it contains an enumerated value. In another endpoint, same microservice, same group who coded it, it sends you back an English string that describes the status. Okay? So, crazy. That's an example of the front-end requirements leaking into the back end. So here's a nice graphic. Here's two sequence diagrams. I'll stand over here. The top sequence diagram is the way you would do this. Here in your browser land, you're talented, superior JavaScript people, and you're making some kind of several REST calls to several APIs. You, the front-end developer, have to know each individual dialect and each variance of the API. So you spend most of your time working out that protocol, that dialect, rather than getting the job done. And of course, you know that if I make 3 elephant calls across that green portion of the upper sequence diagram, that's going to take some time. And that's the time that the user is sitting there looking at you, looking at their thing going, this is a crap application. I don't want to use this. Consider this now with GraphQL, where from the front end you make a query, getting exactly the amount of data that you want in the shape of the object graph that you want to use it. So no post-processing. You send the query over here. Over in server world, those bad server people, because you're all front-end people, we do several asynchronous calls to the APIs in the same data center, in the gazillion gigabit network environment where we've got magically superhuman or super fast computers. And then we send back just the tusk of the elephant that we need to get. So that's a very simple example, but that's a clear example that the low speed portion, the low bandwidth portion of the network has the least amount of traffic on it, the least amount of work, and you get back what you asked for. It's the right shape with the right data in it. But it is not a silver bullet. Everybody happy with the silver bullet paradigm? Okay. You still need to be grown up about your design. A fool with a tool is still a fool. Okay? Remember that friend that you have that gets drunk at the party and you think, we're going to the emergency room of the hospital tonight because he's got drunk. He'll do something and say, here, hold my beer, and then he'll do something ridiculous. So a fool with a tool is still a fool. If you suck at REST, you will still suck at GraphQL. Okay? Your mother's not around. She's not going to clean up after you. You have to be grown up. If your API design is poor, it is likely that that poorness can be fixed a little bit with a GraphQL veneer. For example, in Adform we have a pagination standard in our APIs. So if you want to get many pages of data in a list, you use the parameters called offset and limit. Offset is how far down in the collection you are, and limit is how many things you want. But every so often, you find some motherless soul has used something else like page and size, and you have to slap them. So this is a place where you can do it. GraphQL doesn't solve your poor API documentation. We have a tool that harvests our swagger out of our REST APIs and produces the GraphQL schema. And it takes whatever you wrote in the swagger and puts it in the comments. So if you think you're being funny or hilarious or humorous or crude in your swagger, the world gets to see that. But what you do get is GraphQL is to REST, is to what REST was to SOAP. So it's an incremental improvement. REST was to SOAP what SOAP was to Corba. So I don't know what SOAP did to Corba, but it was only that much better. And it falls all the way down to running on top of sockets. So technology is additive. Uncle Pete reminds you this. I'll talk about it a bit more, but it's very important you know. Who uses it? Well, this is a collection of people who use it. This is about 1/100th of all of the people who are using GraphQL. For example, GitHub decided that maintaining their versions of their API was too hard, and now they offer you a GraphQL API instead. One endpoint, one dialect, rather than 400 or 500 endpoints with 400 or 500 dialects. Easier to deal with. So, at Adform, what did we try? I have to make a confession. I'm not really a JavaScript guy. I saw it 20 years ago for the first time, and I thought it was Satan's vomit. Okay, it was just, I went, oh no, really? What sort of a language is this? So I really didn't do much with it in the last 20 years. It has changed, by the way. It's much better. So I started out doing as an architect. By the way, if you were an architect in the room and you want to be an architect for the rest of your life, don't put the tools down. Continue to code even a little bit so that you can get the technology that you're going to spell on other people. So I looked at the Scala version of GraphQL. A lovely gentleman in Moscow writes it. It's superb technology, but I picked Scala because you can scale it, you can run it in a JVM and it'll run on any platform. It has all of those wonderful words we could use. And I spent 3 weeks on it trying to implement a simple GraphQL server that served, campaigns and line items, and you could do all the queries and call the APIs. After 3 weeks, before 3 weeks, I had beautiful dark hair, and after 3 weeks, it's this color. So I thought, this is really hard. The engineers will, that scene in Shrek where they're going to get the ogre and they've got the pitchforks and the torches? That's what I thought the engineers would do with me if I suggested this to them. I looked at C#, and C# pretty good. The Java stuff's pretty good. But I searched around, and all of the tools, all of the cool things that are being done with Node.js and JavaScript. And I went, oh, shit, really? So after 3 weeks of doing everything else, I sat down and thought, well, it can't be that hard, right? So I sat down with Node.js, knowing nothing about it, and I sat down with several books and 85 web pages or tutorials on how you do this in JavaScript. And I used the Apollo tools, and in 3 days, I learnt Node enough, I learnt JavaScript enough, and I learnt the Apollo tools enough to implement the same thing that I'd done in 3 weeks in Scala. Okay? Very subjective experiment. Okay, I'm an old guy, perhaps I learn things slowly, but that's why we did it. They have mature tools. You can do a declarative schema, so you can actually write down the types in the schema definition language and write down the operations and simply implement the resolvers for a field. Okay, what you can get out of this is a business entity model or a business domain model. This is actually a UML class diagram generated from our schema. So I wrote a little thing that parsed the schema definition language and then spat it out as plant UML, and plant UML draws the picture for me. So what does that get you? First of all, it gets you out of doing that documentation that the project manager says you have to have, right? It's already there. But everybody talks about the same things, a common language, and when you talk about a campaign or about a tag or about a creative, everybody knows exactly what's going to be in it, rather than them having to build it themselves, which is another presentation and a long story we could have over a beer. So here's an example of a schema on the right-hand side in the black. It's just got some types defined in it. And so how long does it take you to work out how to build an agency's Kontakt? Well, it's got a type in there that's a string. It's got a first name, a last name, an address, an email. I don't know what an honorific is, but whatever it is, it's represented as a string. So it's pretty simple. You look at that as a programmer and you recognize it immediately. It's not quite JSON. It's not quite JavaScript, but it's familiar to you. Dead easy. These comments that you see above them, they actually become part of the documentation that's available in the schema. Dead easy to do. And so you can express a relationship like I have here, where advertisers related to a campaign, order and line item are related to each other with cardinality. So one to many, many to many, many to one type relationships. And the same for a tag there. It's nice. You get types, of course, a read model with queries, a write model with mutations, and distributed events with subscriptions. So if you're into CQRS, this sits nicely on top of that. So you can do the C in CQRS and you can do the Q in CQRS quite distinctive. But we have in Adform 300 software engineers and 60 or so teams who build stuff. Having one big schema would be a monster to manage. So we decided that we would build a schema server that engineers could put things in. So there's a hint over here. You can see I've got REST module A, REST module B, and remote module X. So the team that is responsible for that area of the business defines a portion of the schema, the operations that can be done on the portion of that schema, any relationships to things outside the schema, and they own it. So that if you want to do something with a campaign, you go to the campaigns team. If you want to do something with an audience, you go to the audience team. If you want to do something with site tracking, you go to the site tracking team. They own that little portion. And we take all of that and we pull it together in a composite schema. And possibly after I finish speaking, I'll give you a quick demonstration of that because I know you all want to go to the pub. So we invented a thing called a schema module. The schema module has a schema definition associated with it, some resolvers, which is how you resolve a field in GraphQL, and a connector to something. The connector to something could be to REST. So we can consume a REST API. You can put a little bit of lipstick and makeup on it and give it a massage and it looks beautiful. There's a bespoke module. Bespoke is an English word for custom. This is where you code it all by hand. Nobody wants to do that. We have a relationship module which allows us to relate two schema modules together to do that relationship, say, between a tracking filter and a campaign. They're related to each other. And then we have a remote schema module. We might consume APIs from outside of Adform, or somebody's implemented their API in GraphQL and pull them all into a combined schema. So we might get the weather or something like that, or if the flights are late or something, I don't know. So this all gets squashed into a big schema. So this on the right-hand side is essentially a deployment diagram. And you can see we have a schema server. We have some modules here. We talk to our REST gateway, and we have some internal consumptions here. So it's all big possible to have one big schema that is the whole thing combined out of little pieces. So why did we do this? Okay, we wanted to simplify things in Adform. We use every JavaScript framework and probably every JavaScript language that there is, which is too expensive to do. It's exciting and fun to try the new thing, but eventually you've got to say, well, okay, enough. We can't do too much. So we've picked on React as our JavaScript framework. You either love it or hate it, and you can have big arguments in the pub about why that's better over, say, jQuery and all that sort of stuff. I don't care. We just picked one. We have one endpoint, but we want to encourage code reuse. So we're getting standard UI components, not part of my talk tonight, but standard types and standard things, so that when the user sits down at this application, it feels good to them. There's a style to it that they can follow, and it hints to what they do. Okay, so how do we deploy all this sort of stuff? Well, we've just introduced into Adform Kubernetes and containers. Yay! No more no, I won't say no more ridiculous VMs. We still have to have some. But the whole idea is we want to use our hardware better. So we use GitHub Enterprise. We have some hooks in there that allow us to, when we do commits and pull requests, to do some kind of processing. We use drone CI to take what we have done that's been tagged or in a certain branch and build it into a container. This then is made available to Helm. So Helm is the Kubernetes packet manager. And it then does its magic to prepare that to be deployed into our Kubernetes, shared Kubernetes cluster. All of the stuff that we have, we store in our binary repository in Artifactory. So if we've got a lot of stuff that's .NET, so we have a new Get one, we have Maven for the JVM stuff. We've just introduced our own private NPM repository and other things that I don't understand. So, a little bit about containers really quickly. What do we get out of containers? Well, the best thing we get out of containers is we get isolation and some kind of control. So we can limit how much stuff you have in a machine. You can do that with a with a VM, but you put a whole operating system on top of another operating system. It is absolutely stupid to run 3 Linux operating systems on top of a Linux operating system. That's fundamentally dumb, or anything else that starts with F. So we found that if we can go to containers on everything we do, we'll get probably a 4x improvement in how much we can do on a given piece of hardware. So we can do 4 times as much stuff without spending 4 times as much money on hardware. That makes our CIO happy. So to do that, we've got to get away from, we've got a lot of .NET, so we're going to .NET Core as much as we can. We've introduced Node for the first time, and of course the JVM languages like Scala or Java work beautifully in it. So if you're not sure what Kubernetes is magic orchestration that DevOps people know how to do that us as software engineers don't really care that much about. We say to them, we want 10 instances of this microservice running, and they go into the huddle. They get, eye of newt and leg of frog and tail of fox, and they mix it all into the cauldron, and they come out with this Kubernetes environment that just works. Essentially, it's a way to say how many instances of a container that you want running, how to communicate between containers, how to communicate outside, how to check health. It's a marvelous technology. It's similar to something I used in the 1990s called Forte. Forte doesn't exist now, but it was a proprietary technology that did almost the same thing. Things like service objects. We call them petitions, but they would be pods now in Kubernetes. So I get a technical erection when I think about Kubernetes. Okay, so enough of the geeky stuff. Let's do Uncle Pete's advice. So we are not in the IT industry. We are in the fashion industry, and things change every few years. So this is my history, by the way. It's not official. So in the 60s, you know, assembler, COBOL, Fortran, Lisp. Don't program in Lisp. All right, don't program in Lisp. 70s, COBOL, Pascal, PL1, Forth. Don't program in Forth. PL1's not bad. 80s, BASIC came along, RPG, wow, that was a great invention. 90s, we had the object-oriented era where object orientation was going to save the world, remember? And there was a big fight between Smalltalk and C++, C++1. But we got other things like Visual Basic, which sounds terrible, but it got us a long way in the world. And then in the 2000s, of course, we had these buggers come along, wonderful stuff. So if you're not sure, C# is Java that's actually finished. They did a good job, they put it all together, it all worked, everything was fine, they had first-class sort of events and what do you call them? I can't remember what. The listeners, Java was this sort of, Java was a love-in that people used to get together and kiss and hug and talk about how wonderful Java was. And when I first learned it, I thought, oh, it's like stepping back. So now we've got some more cool languages. So JavaScript is not what it was 20 years ago. It's a decent language, a sensible language. You just have to get your head around to the asynchronous nature of it, and then you're fine. There's new things like Scala particularly, and Go is quite a lot of fun. I'm not fond of Ruby, not fond of Groovy. Then you have things like Rust. Rust is what you would write a device driver in. And Swift, of course, is the new language that you get for iOS devices that actually works instead of Objective-C. Horrible language. I mentioned this before, but technology is additive. The first memory was relays, mechanical relays. The next memory was a mercury ripple tank where they would put a wave into a long tank of mercury with a transducer at each end, and you could store bits that were the waves. Okay? Then Dr. An Wang invented magnetic cores, which were great. My first mainframe computer I ever worked on had 48K of memory, K, and it was in magnetic core. Then we had discrete flip-flops, so people would build memory out of just flip-flops. Then we got the TTL and CMOS dynamic and static RAM. If you're not sure what the D stands in RAM, there used to be an S there. It was called static. Dynamic, we can have a pub discussion on that. And the most modern kind of memory, I guess, is non-volatile DIMMs or non-volatile RAM. So that you can have RAM-like speeds but with persistence similar to SSDs. It's super expensive. You've heard of Intel Optane. That's what I'm talking about here. So everything adds. The techniques that we would use today are similar to what we used here. They're just more of them. So technology is always additive. And things change. Things always change. I used to use a telephone like this that you go, and it would send pulses down the line to the telephone exchange to move relays around and servos around to make a connection. And now we walk around with supercomputers in our pockets and we take photographs of our food that we share with our friends because we have no life. Okay, so in your career, technology will change, the tools will change. Compilers still do compilation and linkers still do linking, but they get more sophisticated. Use cases change. I would never have thought that in the second decade of the 21st century, I'd be worried about what this particular cookie is interested in on the internet. If you asked me 10 years ago, I wouldn't have even thought about it. So accept the change, adapt to it, and retrain. In no other industry is there anything like what we do. We have to learn new stuff. We have to do a new degree every 3 years because there's new stuff to do. Okay, talk about project management for a minute. This is supposed to be a puppy that's kicking a ball around and getting lost. Agile is not an excuse for being disorganized or being disinterested. It's a way to get the job done. It's not a club, it's not a social group, and it's not a cult. So in all of the work we do, so we do work because someone's paying us. Someone's paying us to play with these wonderful toys they bought us. This is another animation which I can't show you because my monitor didn't connect. But Murphy's Law, entropy, third law of thermodynamics, you know, hot things get cold, organized things get disorganized. Remember when you were a teenage boy in your room and your mother yelled at you and you cleaned it up? This doesn't happen with girls, by the way. And after a few weeks, it would be messy again, and you didn't make it messy, it just happened all by itself. That's entropy. So anything you haven't tested for a while will break. If the unit's tests passed 5 months ago, and you haven't touched the code, I guarantee you that it will be broken. Because there are gremlins and monsters that live in the world of cyberspace. So once again, retrospectives and refactoring. When something terrible happens, like Samsung, this is a nice animation of them erasing dynamite out of there, work out what went wrong. It's embarrassing. Sometimes it's your fault. You have to fix it. As a junior programmer working on the first email systems, I deleted half of the source code through a simple error, and that was in the days before we could just roll back to the previous version. We used to just copy files. And of course, refactoring. So this is an animation of a kitten throwing things off the table. Refactoring is good. If you don't refactor, you end up with this big hunk of code that does something that nobody understands, and people are frightened of it. And after 15 years, it stays there because nobody knows anything about it. Okay. So this is another animation to say that no matter what you do, regardless of how much fun it is at work or what project management dialect you're using, nothing matters unless your code runs. There's nothing more soul-destroying than writing some wonderful code and it never going into production and nobody using it. So remember, you get paid for a reason. We get to play with these nice tools, even when you get old like me. I'll be 60 years old in 2 months' time, and I still write code because it's immense fun. Someone pays us. They pay us because either they need to make a profit, or if you work for government or the public sector, we're doing something for the community, so the taxpayers are paying us. So we get paid for a reason to produce a result. So never forget that running code is the most important thing. And that's all I have for you in this somewhat Frankenstein presentation. Does anybody have any questions? There's one question up there and a gentleman with the blue shirt.
Okay, so
nobody's coming with a microphone. Just yell.
first I would like to thank you for the presentation. It was awesome. 1, 2. Okay, so my question is, if we have a project with a backend in Scala and with a REST API, do you think it's worth it to go to the GraphQL? And
Okay.
where is the breaking point when it's worth or not worth it? And the second thing, if we have a backend in Scala, we want to start a new project in Scala. Do you think we should start with something like Sangria, or maybe make a REST API in Scala and then with Node.js make a GraphQL API?
Okay, that's a very interesting question. So my first question is back to you. Is your REST API public, or is it just for your own use?
For own use.
Okay. So, and how many endpoints in your REST API?
I guess not so many like right now, about, I don't know, 15 maybe.
15. Do you expect it to go from 15 to 500 or 15 to 100 at some point?
That's it.
Okay. So the strength of GraphQL, as I said, one endpoint, one dialect, and you get the object graph back in the way that you request it. So the front end is easier. In fact, the front end developers can forget about the back end. And there's some other technology in the Apollo APIs. There's all sorts of caching that you can do along the way so you don't lose the parts that you're interested in. Caching based upon the query, not based upon the entities. So back to your question. You could start today with a Sangria implementation, which is quite a good mechanism. If you're a Scala dude, it's much easier than if you're not a Scala dude. That's really hard to do. So you could start with that, and you could have a hybrid. You could have REST, and you could have GraphQL, and over time you could implement a migration plan to move the REST functionality into GraphQL and then deprecate the REST. You could also implement the schema in GraphQL and then use the resolvers to call the REST in the interim. So you could make a switch from your REST implementation to GraphQL today, preserving the REST, the investment you've already put into it, preserving the interfaces for legacy code, but having this new interface over here. So the next question you had is about whether we should just keep our Scala as REST and then put a node on top of it. That's a software engineering decision about money than it is about technology. And the reason I say that is to add a new technology to a company is costly because there's already an investment in time and money and knowledge in the software engineers who wrote the original thing. So that's a harder decision that you'd have to work out for yourself. Now let me just comment on engineers. So we're all software engineers here, right? Our job is to make something out of nothing. Okay? We are more creative than Chopin or Van Gogh or, I don't know, who else is creative? Other entertainer people who get paid lots of money. We do more stuff. So let me get this right. All of you at some point while you're working in the day, sit there, you're thinking about a problem and you look off into the distance and you see all these balls in the air that you're juggling. Nobody else sees them. It's just going on in your mind. And if some bugger interrupts you before you put those balls in the right place, you have to go back 3 hours and start again. Right? All of us do it. We sit there and we imagine all of these wonderful things, and then we write a few lines of code. And those few lines of code are 3 or 4 hours worth of thinking work, and there may be 50 lines of code. So as software engineers, we're different to everybody else. People sometimes feel that we're not very social and we don't like to get involved and we just sit amongst ourselves. There's nothing quite so magical as when you do the thing you had in your mind becomes running code. You get that technical orgasm that you can't share with anybody else because it worked. I did it. I did that. And you're really happy about yourself. And at the end of it, you feel good. So there's a lot of investment in software engineers. So we invest in technology and time and domain knowledge and thought and process. So adding a new technology costs money, and the decision to add it has to be based on a valid reason. Now, you might have a valid reason, and it's not because Uncle Pete said you should do it at a meetup. It's a business decision. When you want to justify that to your bosses, take them the options. Give them a reasonable guess on the costs of each now and in the future, and let them make the choice. It's their money. Okay? Any other questions?
Thank you very much.
There's one here, and there's one right up the back.
Maybe it's not regarding the topic that you have, but what was the most interesting bug that you've ever encountered?
The most interesting bug that I've ever encountered.
Or the worst bug, if you
All right. Okay. In the late 1980s, there was a bug in the operating system that ran on the Wang mini computers. It was narrowed down to 5 lines of assembler code in the operating system kernel. So when you're in the operating system kernel, it's like having a bare machine that you can do anything you like with. It's not protected in any way. And we found a bug in these 5 lines that under the most unusual circumstances would cause the process scheduler to schedule the wrong process. So it would schedule to go onto the CPU a process that was still waiting on an interrupt. And nobody knew what these 5 lines of code said. In fact, in the assembler documentation next to each line, it just said, weird shit, don't change it, it won't work. And apparently it was self-modifying code that was very, very fast. And we got it better, but we never got it fixed. Never got it fixed. So there was somebody up the back who had a question. A gentleman there with his hand up.
Poczekaj.
I'll have to run.
Kto?
All right. First of all, I have to say I really enjoyed your presentation.
Thank you.
And it was just it touched upon some subjects that I only considered as history because they're older than me. Like, you know, I immediately thought, okay, this guy's gonna be talking about Sun RPC and stuff, but that's not the point. The point is that I have been trying to wrap my head around the GraphQL a few times already, and one thing has always bothered me, and it's exactly the same thing as with REST. And that is, well, I build mostly CQRS, so command query responsibility segregation apps, and the model/command disparity has always bitten me, and it's an issue I couldn't ever tackle. So, like, it's the same issue in REST as in GraphQL. How do you represent business commands that carry intent in GraphQL terms? Because if you're operating on an entity model, then it becomes quite a bit unnatural to post commands to them, like if you're operating on fields and transforming them. Do you think it's applicable to problems which require domain intent and domain commands?
Absolutely. So what I didn't talk to you about tonight is that I showed you the kindergarten version. I showed you the notion of a type and a field inside a type. Each one of those fields inside a type is actually a command. It's a command to get something for you or to do something for you. You can put parameters on them, and you can then have a resolver that executes that command. So at the really base level of GraphQL, you have an object called, or a type called query, and you have a type called mutation, and you have a type called subscription. You can actually call them anything you like, and in there you put in the root level functionality that you're interested in. So if you step away from the types themselves, types solve the problem that we need for the business, but what the business is built on is commands. So it would be theoretically easy to build a function-oriented server where the functions could be called from the front end using a GraphQL invocation. So GraphQL is just a protocol, and it has strong typing, of course, but the flexibility in the operations that you can do, both the read and the write, is quite great. So one of my dreams one day before I retire is to go from this gaggle of stuff we have at Adform, which all works and was all done for the right reasons, to something that maybe is more, rather than us having services, microservices running in Kubernetes, that we might have functions that are callable. And so that whole notion of serverless, what's that stuff in Amazon that they give you where you can write functions and it's just
Lambda.
That's it, Lambda functions. So we're going, I think that is the way that we could get the scale we need in Adform. To give you an idea, Adform has 2,500 physical machines in our own data centers. We process 2.3 million bid requests. That's requests to place ads in front of people every second, every day of the year. In fact, when it gets up to Christmas, or when the Indian IPL League is playing cricket, that's when the demand gets very, very high. We have 24 terabytes of millisecond data. So we can read or write a piece of key value type data in a millisecond. We have 500 terabytes of columnar data. So data that's in columns, and then we don't do 1 million transactions a second there, we do sort of 50,000 a minute. And that's column type things, you know, where the cat has got blue eyes and it's got one leg and it lives here, that kind of where clause in that. We have 7 petabytes of raw data, and this data floods in because all you people click on things in the internet. And, oh, don't worry, we don't know about you. We know that your cookie has done something, and don't be concerned about the questionable websites that you may have visited. It's just like noise. Everybody does it, so it disappears. And the people who don't do it are liars. Okay. So we process all of this raw data. We have 13 months worth of it. We take it all and we stuff that in the end of a big Spark cluster that takes it and turns it around, and data scientists wave their voodoo things over it and come out with insights that produce us audiences and things like out the other end. So we have tons of stuff, and lots of fun to play with. Absolutely lots of fun to play with. But you don't want to be playing with it on the months leading up to Christmas and breaking it. That's when all of a sudden you get very popular, like the CIO calls you, and then you might not have the job the next day. Any other questions I can answer? Yes?
I have a question not related to your presentation, however, with your industry. Do you use Adblock or uBlock privately?
No, I don't. I don't really care. So everybody's worried about privacy on the internet. Here in Europe, we have some very strict laws. So we routinely go through any data that we may have captured about you and clean it if it has any first-party information in it. That's routine, and I mean routine, that's probably every hour that we do. If ad blocking is an interesting thing, you want to block these pop-ups that annoy you, but don't you want to be advertised stuff that you're interested in? I mean, I'm more interested in knowing about the cheapest flight to Australia than I am about which shoes I can buy in Italy. So, you know, ads are a part of life. The free stuff that we get, all of this stuff we get for free on the internet has to be paid for something. And it's done because a publisher sells a portion of the website or a portion of the game or the application to an advertiser. And so they give you all of this stuff for free because they get funded. Just like buying a magazine. You buy a magazine in the old days when people read magazines and you turned the pages by hand, there's an ad someplace. So it's the same concept. Adform doesn't know anything about you personally. Google knows everything. Absolutely everything. So it would be fun to play with their data. I sit with a bunch of data scientists. Any data scientists here? They're spooky people. Data science is this cool stuff. Remember at university when you did that statistics subject in maths and you hated it and you did it just enough to pass, then you went on to computer science? Well, data scientists is the ones who really found that interesting, and now they get paid tons and tons of money. Any other questions? I think we need to wrap it up. One more.
So you said GraphQL is to REST what REST was to SOAP.
Yep.
So my question is, what will be to GraphQL what GraphQL is to REST?
Absolutely. So it's an interesting question. As I said, all technology is additive, and when you get as old as me, you'll have seen a lot of it. So there will be something that is more valuable and useful and capable in the future. I suspect that it might be something more Lambda-ish type functions that sit atop it. There will be something else that will come along. Technologies pop up all the time. Not always the best ones survive. Well, look at Java. I mean, things pop up and somebody leads for a while and it becomes old and then you move on to something else. So be prepared for change. I expect technology to change at least 4 more times before I retire.
Anything on your radar right now?
All right, so don't tell anybody. One of the latest pieces of cool technology, well, you've all played games, right? You know what a graphics processing unit is, a GPU. It's this processor, NVIDIA make them. They usually have 2,500 or 5,000 GPUs in them. They're really good at doing floating point arithmetic. Really, 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 really good at it. So, much faster than a CPU. If you have a task that you can parallelize out to 500 things at once, like TensorFlow, or columnar queries in a database, you can get the work done faster. So, technology is emerging now that's got nothing to do with gaming that uses GPUs. So the first one is TensorFlow. If you run TensorFlow on a machine that has no GPUs, you get the right result because all these little tensors are little floating point operations that are done many, many, many times over a data set. If you run it on a GPU, it will be significantly faster. And if you could run it on a cluster of GPUs, then it'll be many times faster. So machine learning can occur quickly. Columnar databases. There are 2 columnar databases that I'm looking at right now. One is called MapD, and the other one is called ScreamDB, SQREAMDB, that use GPUs specifically. So, wouldn't you like a columnar database that had no indices on it, no indexes on it, and that you could cast any column to anything else and not have a problem, and do it all in seconds, and then compress all the data so you can put 60 terabytes down into about 8? Well, that's the kind of thing that you get out of a GPU-based database. So GPUs are a thing that's exciting. All right, I think we're done.